Okay. So did you do the question? You can answer the quiz, the post I put there. So I want to know if you answer the question. Let's go through the question, but we're also going to see how much can we do from the question rather than just the question. So let's take more information from from this specific question. Okay. So the question, which is, or it was a question done in Houghton, say the velocity versus times graph below illustrate the motion of an object that is initially traveling east. So the direction is important. All right, I'm going to write it here and then I'll show you just now. It's traveling east. That is an important data. All right, and then you see the graph there. What is the velocity of the object at t0 and describe the motion of the object between A and B? But we are going to describe the motion of the object through the whole graph. So let's take as much as we can from the graph. All right. So here I draw the graph of velocity versus time. Whenever you have a graph, either whatever graph you have, the first thing you have to do is to identify what is the type of graph. Here we have velocity versus time, because different graphs have different things to do in there. Right. So if you don't know that, then you will be able to answer the graph. So this is our graph. The direction is east. And then you need to know that the initial velocity of the graph is always towards the left, starting from 0. At 0 time, the velocity was 10 meters per second. So 10 meters per second was what we call initial velocity. All right, that is the initial velocity of the whole motion. Now this motion have sections. It has section AB, BC, and CD. We are going to describe the motion of the object from A to D. The question only asks for, I don't remember what does the question ask, but we're going to answer a little bit more than just the question. The question asks, let me see, A to B, but we are going to answer the whole motion. All right, now, whenever you see in a velocity versus times graph that the line is parallel to the x-axis, that means that velocity is constant. All right, so if you see that there is a parallel line, for instance, let's say you have an extended version here, that means that velocity at that point is constant. If velocity is constant, acceleration is 0. So the acceleration at this point, and let's write it with the same green, acceleration there is equal to 0. I'm going to use the symbol A for acceleration. Here, which is an extension of the graph, acceleration is also equal to 0. All right, so once more, if you have a parallel line to the x-axis, it means the velocity is constant and the acceleration is 0. So that is important thing. Now, for how long was the velocity constant and acceleration equal to 0? If you go to the time, for 3 seconds, this graph is in seconds. So for 3 seconds, velocity was constant. That is what the question asks. So we can come here and write, for instance, AB, velocity constant. That is part of the explanation here, guys. Acceleration is equal to 0. All right? Time 0 to 3 seconds is 3 seconds. Remember, you can also write S, but no sec. And I guess you know who I'm speaking about, that uses sec instead of seconds. So you cannot use sec. All right. Now, something important as well. Velocity is constant in what direction? They say it's moving east. East is positive. So this positive side here means east. The negative side of velocity means west. So all this here is west. I hope it's clear. Remember, I have somebody to help me today with the messages there. You can tell me if there's any question, you can ask. All right? So I hope this is clear. So here velocity is constant, east. In the east direction. Let's go to BC. What happened from B to C. All right, B to C. What happened from B to C? You can see that the velocity went from 10 to 0. So velocity decreases. So you write the velocity decreases. Velocity decreases. Acceleration is constant. How do I know it's constant? Because of the gradient. Acceleration here is constant. It's not equal to 0, it's constant. It's a straight line. If you get a straight line, that means that acceleration is constant. So we're working in BC. Velocity decreases. It's going from 10 to 0. If you want to be specific, be my guess. Acceleration is constant. Now, to keep about direction, velocity decreases east, in the east direction. Velocity decreases in the east direction. For how long? How long the object velocity decreases? Time was equal to 3 to 5. So it's 1, 2 seconds. 2 seconds. This one is the description for B to C. Now, CD is a problem. Remember, I am going a little bit more than actually the question. The question only asks for AB. No, no good. We're going to explain everything because tomorrow you don't know what is going to happen. So CD is from this point to this point. Now, the velocity is going from 0, and this is the tricky part, so I really want you to pay attention here. All right? Velocity is going from 0 to 10. Velocity increases from 0 to 10 meters per second is part of the question. Velocity increases from 0 to 10. But why is negative? Because it's west. Now, when you have this graph, guy, everything that is above the 0 of the x-axis is the positive direction. For instance, east. Everything that is below the x direction, the x-axis, is going to be the negative direction. For instance, west. If positive is right, then below the x is left. So that could be tricky. I hope you get clear here. So velocity increases, that is from C to D, west. In the west direction. So what actually happened is this object was moving constant, start braking, stop for just millisecond, the object stop and start moving again. That is what actually happened up until D. Remember, at D is the end of the question. So we're going to stop there at D. This little part here I added. So now, any question about description of motion? Here, I also forgot, the acceleration is constant. There is somebody that didn't understand. I want to know if should I go everywhere. Go back. I think we should go. Yeah, my helper say no questions, but there's somebody that didn't get clear. So let's repeat real fast. I don't want to take too long. If you have a line that is parallel to the x, it means the object is moving at constant velocity. Nothing to say. If the line is on the x-axis, like for instance, if the line is here, that means that velocity is equal to 0. The object is not moving. When the line is moving towards the x-axis, above the x-axis, the velocity decreases in the positive direction. Positive direction is east. Starting the question with that. If the graph or the line goes straight line away from the x-axis in the negative side, that is in the opposite direction. In all the cases, acceleration is either constant or 0. We don't have acceleration that increases or decreases, all right? So I think that is everything. Now, the next question, they ask you to calculate the acceleration. You need to know that the acceleration using the graph of motion, acceleration, is going to be equal to the gradient. Is equal to the gradient. All right, so whenever in this graph you have to calculate acceleration, all you have to do is to look for the gradient. End of the story. Is really easy. So what is the gradient? Now, how to calculate gradient? That is maths literacy grade, what grade are you? 5, grade 5. M, which is the gradient, is equal to change in the y-axis divided by the change in the x-axis. Guys, you have to identify the side of the graph that you've been asked. This is the part of the graph that we're dealing with, from B to D. All right, so what is final? Okay, let's continue. Let's break this one. This one is equal to final y minus initial y divided by final x minus initial x. Let me tell you, 100% sure this is going to be in the exam tomorrow, for sure. So now here, let's see which one is final y. You go to the y. You start in here. This one is initial. This one is final. It's from B to D. So the final will be 10. That is final y. Negative because the negative is there. So it's minus 10, minus 10, minus because the minus is there. Initial y, 10. Divided by x. Final x, 7. This is final x. Initial x, 3. 3. Is that the message? Okay, but this is another message. It's not from our group. It's not from our group. So now m, the gradient is equal to, this one is minus 20 divided by 7 minus 3 is 4. Are you with me? So 20 divided by 4 is how much? Antonio, how much is 20 divided by 4? 5. Negative. This is meters per second square. What does the negative mean? Negative means direction. Can you see there? Let me see. Yes, you can see. So this means direction. So the final answer, acceleration is equal to 5 meters per second square west. There we go. Very, 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 very easy, guys. Explain. So, all right. So this one is in terms of acceleration and description of motion. There's not much more. We have to speak about displacement and distance, and this one is important. We're moving on now. In terms of displacement and distance, when you're doing this graph, there is a difference between distance and displacement, and you can get a mistake. If you're going to calculate distance, in either case, you calculate the area. So displacement is area under the graph. Area under the graph. All right. But now, for displacement, of the whole motion, is going to be the area top minus the area bottom. All right? That one is tricky. If you want to calculate the displacement of the whole motion, is the area on top minus the area at the bottom. All right? If you calculate distance, it's going to be the total area. And let's explain that one. So I'm going to erase this one because I guess now we are done. Then my helper is back. He's going to sit and manage the messages. Please, sir, help me with the messages there. Oh, thank you. That's for me or for you? For me? Yo. All right. So now let's explain about displacement because it's a tricky part. I'm not quite sure if it's going to be in the exam, but it could be. First, area under the graph. Let's identify the area under the graph. on this side here, the area, and let me see what color, my colors are finito. The area will be this part here. That is the first area. All right, second area could be this part here. Another area could, for instance, be this part here. Remember, this is not part of the question. That one I added when I was explaining. So let me remove it. Let me remove that part, okay? That little line is not needed. There we go. So now, there is a difference between displacements and distance, but let's calculate each of the areas, right? So this area, this area here is a right angle. So it's base times height. This area here is a triangle. This area is half base times height. This area here is going to be half base times height. So those are all the areas of the graph. Right? Now, there is a difference. If you've been asking the test to calculate distance or displacement, you're still going to use the area, but differently. If you're going to calculate distance, you're going to add all of them. If you're going to calculate displacement, it's the ones on top minus the one at the bottom. For example, here is going to be base times height, or let's do the following and rather write area 1 plus area 2 plus area 3. But if you're going to calculate the displacement, will be area 1 plus area 2 minus area 3. All right, so that is the difference if you calculate distance or you calculate displacement. If you calculate the displacement of the whole motion, you have to subtract. Okay, so for example, here, the first area, we can do it there. I'm running out of space once more. I hope here is enough space. Area 1 is base times height. This one is equal to 3 times 10. That is 30 meters. Remember, it's area, but it's equivalent to distance. So actually, we are not calculating area. It's no meters squared. Second area is equal to half. The base is 3 to 5. It's 1 and 2. The height is 10. So 10 times 2 is 20, divided by 2 is 10 meters. All right. And this is area 3, which is half. Base is 5 to 7 is also 2. And then here is going to be another 10 or negative 10. If you want to calculate the negative. All right. So negative 10, for example, you get minus 10 meters. You see? Now, let's calculate the distance. If you calculate distance here, I'm trying to get all my colors, then this is going to be 30 plus 10 plus 10. This one is a beautiful 10, guys. Plus 10 plus 10. 20, this is 50 meters. That is for distance. If you calculate displacement, it's going to be equal to 30 plus 10 minus 10. That is equal to 30 meters. But now direction is positive answer, therefore is. We are done in terms of distance and displacement. No, it is negative. You see, those are the questions. It is negative here. It is negative here. But you only use the negative for displacement. This negative, right? This negative means direction. If you calculate the distance, you add all of them. If you calculate the displacement, you write as negative. No. A learner has to walk to the shop to buy bread. After walking 200 meters, he realized that he does not have enough money. I think we did this question. And go back home. It took him 4 minutes from the time he began walking until he returned to the house. Calculate the following. Determine the learner's displacement. Now, for only one mark the displacement. All right, we're going to do that one. Just making sure. There you go. There is no question. So I'm going to erase it. I'm going to erase it so I can do that question on the person that did not have money to go to the shop or go the money. So let me clean once more my board here for you. Right. So now let's see. I'm going to leave that part just in case. What is happening in that question? This is the house of that person. They're doing the cooking. That is the house of the person. The person is cooking at home. All right. I just want to know if there is a direction given in the question. I don't quite remember. Walking 200 meters, he realized to the shop. It's just towards and away from the shop. So he walked 200 meters in that direction. This one is 200 meters. This is the shop. All right. That person walks 200 meters towards the shop and 200 meters back. The time that the learner or the child took was, and let me just look quickly, it was 4 minutes. It was 4 minutes. So the time here is equal to 4 minutes. 4 minutes, remember you cannot work in minutes. So this one will be 4 times 60. All right? So how much is 4 times 60, guys? Okay, so we have here 180 seconds, nah? Are we right? 180 seconds. All right. Remember, no seconds. So now the first question says, what is the displacement? Well, you don't have to calculate, but if you want, you can say that displacement is equal to final position minus initial position. All right. The final position is house. The person starts from home and it ends at home. So it's going to be 0. The displacement is 0 meters. There were not displacement. The distance, however, will be 200 plus 200. So it's going to be 400 meters. Distance will be the addition of the whole motion of that person. Displacement will be 0. I hope this is clear. It's quite simple. 240. Oh my goodness gracious, where to? 240. What am I thinking, huh? We didn't use it yet still, but we're going to use it. They say differentiate between average speed and average velocity and calculate the average speed. So for the average speed, you need the distance. That is why we stop here. Okay, so now we go here, guys. What is the difference between average speed and velocity? I want to know, you see there? And velocity? Yes. What are the difference? And let's speak about all difference. Let's speak about all difference. First difference. Difference number 1, speed is scalar quantity. Velocity is a vector. That is the first difference between them. Second, speed is distance divided by time. Velocity is displacement divided by time. Those are the main difference between distance and displacement. And just to finish, we are going to finish in a second, they asked to calculate the speed. So we can somewhat do it here. This one is 400 is the total distance traveled divided by the time, which is 240. 400 divided by 240. Guys, I don't have my calculator. In the next question, I will bring the calculator. How much you get there? It's a good time for you to interact. Oh, thank you, sir. There's my helper. It is 400 divided by what? 240. 1,67. Remember, you have to round off to 2 decimal places. 1,67 meters per second. No direction needed. No direction needed, guys. No direction needed. And with this, we end the question. I hope you understand. I'm now waiting for questions.